Right, welcome back to the fifth part of, hopefully in the final part of the Code Signals arcade walkthrough. So now we're going to be starting on problem 48, and let's go. Okay, so it's called, is digit determined to given character as digit or not? Okay. All right. I guess it's just okay. So in Python, you can just have a function called isDigit, and that's it. Right. So cool. Yeah. I mean, it's just as simple as that. But I guess there are some ways that you can do with, like ASCII numbers and stuff like that. But we're not gonna go through this because like it's just kind of meaningless, and you need to know this function that exists. So just memorize this function, or maybe just be aware of the fact that it exists. Right. So you can always just Google it. So that's that. All right. Line encoding. Okay, so what is this? Given a string, return the encoding defined as follows. Okay, first the string is divided into into the least possible number of disjoint substrings consists of identical characters. Okay, for example, all right. Next, each substring with length greater than 1 is replaced with a concatenated of its length and its repeating numbers. Okay, yeah. Finally, all the new strings are concatenated together the same. Okay, gotcha. Yeah, so it's just basically like zipping like string, I guess. So trying to make the string as short as possible, right? So that's kind of the idea. Okay, so I guess how should I approach this? We really don't have to follow this guideline. We can just jump into this format immediately. We don't really need to like create a list of these things and then jump into the next. I mean, you can, but I don't think there is any need to create like an intermediary list to do so. But we'll see. Okay. How should I solve this? Hmm. I guess just basically. You know what? Let's just follow this, guideline, and then we can step-by-step process. Let's just follow this step-by-step process, right? And then we can. I think that will be more organized. So, okay, for I in range, length of s, and I think what I can do is go until like 1, right? Because I'm gonna be comparing it to the next string. So. Is that a good idea? I think that's fine idea. So basically, like, I guess let's just disjoint no substrings. Okay, how should I do this? Okay, I'll just call it like parts, and then if length, not length, s of I is equal to s of I plus 1, I think let's see. It is not equal to, I guess. So I guess what I can do is this. If it's not equal to, then parts.append. Then I need to know the previous thing, right? Okay. That kind of sucks. Okay, if it's equal, then what should I do? Okay, let's just do that. Do this. So the length is minimum 4. Okay, so which means what I can do is just add the first character, let's say, and then start from the first and then go until that. Okay, so we have already like a string in here that is only maybe like A or something, right? So now what I can do is compare it to the previous one. And if it is the same, right, then we just say, okay, parts of -1, which is the last one, plus equals the current string, which is s of I, right? And else, what I can do is parse out append the current string. So let's just do this and then see what happens to the parts. Return empty string, and then just see the outputs. Console output. Okay, yeah, this is exactly what we want, right? So the trick was to have like initialization of the first string and then start from the one and then look at the previous one. So I think that this makes it much cleaner. All right. Cool. Okay, now that we have this, then we just loop through the parts, right? So let's just do like result and then loop through the part of in parts. Then if length of part is greater than 1, result dot append length of part plus, now we have to convert this into a string, so str plus the character, right? So part of 0. Let's just do that. And then else, if it is just length of 1, then we just res dot append the part of 0, right? And then simply we just return the joined response. So that's that. And then let's just test this out. Okay, it works. Great. Cool. All right, so that was the whole process. So basically this step was for converting into this kind of format, and then this part was converting this format into, you know, the numbered format. So that's that. And then the time complexity in here is kind of tricky because like every time I'm like appending a letter, right, then that, you know, it creates a new string, and then it can get messy. So obviously this is O of n, and then the space complexity is also O of n because there can be like as many parts as the string itself, right? So obviously it's that, but the time complexity can be like, I guess it's still O of n in this case. Because let's see in here. So we have, I guess it's kind of like O of n because like if there is like multiple like repeated characters, right? You just keep on adding, and then but also the total length is decreasing. So it's kind of debatable whether it's O of n, but I think it's O of n. Okay, let's just move on to the next one. Submit that. Okay, cool. Chess knight. Okay, what is it saying? Given a position of a knight, a standard chessboard, find a number of different moves that knight can perform. Okay, cool. All right, so if you know chess, then it's pretty simple, self-explanatory problem. But if you don't know chess, then basically a knight is this piece, and then it moves into like L-shaped, right? So it can move like this, or it can move like that, it can move like this. You know, there's like 8 different positions if you're on the center of the board. But if you're like on the corner, there's only like 2 moves, right? So essentially you just have to output like, hey, like even the cell coordinate, how many moves are there possible for the knight? Okay, so I think on the previous problems we dealt with a lot of like chess piece stuff. So I think this, if you watch those, then it's going to be really helpful. So essentially, I think we need to convert these coordinates into numbers, right? So what I would do is like cell of 0 and then convert that into like ASCII number, right? And then minus ORD of A. So that converts into ASCII, and then I'll just add 1 because the coordinate actually starts with 1, right? Not with 0. So I'll just add 1. And then the Y coordinate is actually cell of 1 and then converted into integer. Okay, so those are the X and Y. And the knight moves is like there's, let's just call it directions as there's, and then you can move to 1, 1, 2, minus 1, 2, 2, minus 1, and then minus 1, minus 2, and then what else is there? So you can move this here, and then I guess minus 2, 1, 1, minus 2, right? 1, 2, 3. Okay, so there's 1 missing. We have that. Okay, so both of them are minus. That's missing. Okay, minus 2, minus 1. Okay, so these are the 8 directions, right? and then you just basically move through like dx, dy, which means delta x, delta y in directions, and then check if, let's just do like cur x, which is current x, which means x plus dx, right? And then the current y is equal to y plus dy. So, I mean, if you're confused about this notation, it's, pretty simple. This respects, corresponds to this position. This corresponds to this position. So this is just, a simple way of like saving space. Like if instead of writing it 2 lines, you just write it in 1 line, right? So it looks pretty clean once you have like maybe 2 variables. But if it's more than 2, I wouldn't recommend it. It looks really bad. And then what you can do is like if it's in the border, right? So if it's x is greater than not like that. I think we can do is greater than 0. Oh, yeah. And then less than 9 and 0 cur y less than 9. Okay, so this means it's within the border, right? Then what I can do is like have a count at 0 and then count increase by 1 and then return count at the end. Cool. Yeah. That's it. Yeah, and then there's just no time or space complexity in this problem, right? Both of them are like O of 1. Okay. Let's do delete digit. Okay, what's this? Given some integer, find the maximum number you can obtain by deleting exactly 1 digit of the given number. Okay. I guess I think the simple solution to this problem would be just convert it into a string and then keep on deleting 1 digit at a time and then just note the maximum. I think that's a good approach. Let's just do that. So s is equal to strn. That's the string notation of the digit. Or maybe I guess you could just even convert it into like list of digits. Okay, let's just do that. Maybe that's more elegant way of doing it, because typically converting into string is kind of like shortcut or maybe cheating, some people would say. So let's just do that. So digits is like that, and then while n is greater than 0, digits dot append n divided by 10, n equals n 10, which means I can do that, right? So that's going to be the digits, but it is reversed, right? So what do you do? So digits equals digits like that. That's going to be reversed. But I think there's like a reversed function, I believe, but I forgot. I think, yeah, we'll just go with this. So basically, you're just reversing it because this is going to be appending from the back, right? So now you have to reverse it in order to get the correct positioning. So now what I can do is in range length of digits. And then let's just do like max num is equal to 0 at first. And then keep on deleting it, right? So yeah, I guess like what's the best way to do that, I guess? So let's just do like d equals digits of that. So we'll make a copy of the digits, so because we don't want to modify the original one, right? So let's just make a copy and then do pop of I. So pop, it would be removing that digit from the list. And then what we do is basically combine all these digits to make a number, right? So I think what's the best approach to do that? For I in range, j in range, because it's nested loop. And then length of d minus 1 minus 1 minus 1. So we have to go from the back in order to like convert, like for example, we have 153, right? So in order to convert this into 153, you have to multiply this by 10, right? No, sorry, just add this and then multiply this by 10, multiply this by 100 essentially, right? But yeah, so let's just do that essentially. number would be 0, and then number plus equals d of j. Or maybe it's not that simple. Let me see. So you're going from the back, and then you add it, and then you multiply it. Okay, so I guess number equals 10 first, and then you add it. Oh no, that's not gonna work though. So I guess it's we have to start from the beginning then, in order for this to work. So yeah, so from the beginning you just go 1, and then add 1. So it's gonna be 0 and 1, and then you multiply the 1 by 10. It's gonna become 10. Add 5. Okay, I think this is gonna work. And then you have the number, and then max num is equal to max of number or max num, right? And then return max num. So this is a really troublesome way of doing it, because if you don't want to convert it into string, this is the way to do it, right? So let's just do that. Okay, this works. Yeah, this is really troublesome. Let's just do it with the string conversion, right? So let's just convert it to string first. And then, oops, str and, oh, what is it? Okay. Now let's just do this thing, right? So now it's converting to string, and then I in range, length of s. And then we can do like the, what is it called? Like subtracted s, I guess. So let's just call that ss. Would be s of I, and then plus s of I plus 1. Yeah. So this is going to be our new number. We're just going to delete the ith one, right? So that's going to be our new string. And then the max num would be 0, and then max num would be maximum of max num. And then we have to convert the ss, right? And then return max num. So this is much simpler, I would say. Okay, yeah, same thing. But this is using string conversion into integer conversion. Okay, that's that. And in terms of like time and space complexity, I don't think there is much to say in here, because like the length of the number is constant, right? So that's why both of them are constant essentially. So let's just do that. All right, submit. Okay, land of logic. Okay, so this is the last island. Okay, land of logic. Let's go. All right, define a word as a sequence of consecutive English letters. Find the longest word from the given string. Okay. Longest word. But I guess there is no longest word given a string, consecutive English letters. Okay, I guess. I wonder what are gonna be like the special characters though. That would be the most interesting. Word given a string. Okay. In the word string, longest sequence of consecutive English letters. Okay. I think, okay, so let's just do like chars, and then list of special characters, right? So let's say question mark, like that. Okay, let's just assume these are the special characters, and then for C in chars, and then we're gonna be doing some sort of like cleaning up, right? So we can do C equals, let's just do the space. I think that's a better approach. Okay, and then we basically cleaned up all the special characters now, right? So now we can do is words text dot split. So this will split it with the spaces, right? And then max length is equal to 0 for word in words. Max length would be okay, I don't think I can do it with max, because we need to return the maximum string. So max string is that initially it's going to be empty string, right? So if length of word is greater than max length, then the max string would be the word, and also the max length would be the length of word. So then we can return max, not max length, max string. Okay. All right. So this must be like some sort of other. Oh yeah, we have to make it lowercase too. I think what's the best way to do it? I think not lower, but split. Okay, I think this should work. Oh, now then I have to return the. Okay, maybe it's not lowercase. I was mistaken. So what is wrong? What was wrong with the previous one? Console output return value. Oh wait, what? It didn't replace it. Replace C text. This is so weird. I'm not sure why it didn't replace it. Okay, let's go here. Yeah, I mean, it should replace it. What's the return value? Okay. Yeah, this is so weird. C in chars. Oh, sorry. Yeah, this should not be like that. It's just going to be a list of strings, right? Yeah. There's no array in here. Okay, so this is one of the special characters. Okay, cool. So, I mean, I don't think this is that a good of approach. I guess what I can do is do some sort of string building. Let's just do that then. So S, let's just call it S, right? And then C in text. So we go through each character, and then if C is alpha, it's gonna be like an alphabet character, right? If it is, then I can add it to that, and then once the S is built, I can. Oh wait, if it is, then if it's not, I have to s dot append like a empty space. All right, so that's really, really important. Okay, so now I have to join the s and then split it. Okay, I think that should work. Okay, yeah, this is much better solution, I would say, because we don't want to have like limited number of special characters, right? Cool. All right, so in terms of like time and space complexity, this is just like O of n because I'm creating like a new list, filtered list, and then also there's like one loop and then another loop, right? That's it. Okay. Next question. Check if the given string is correct. Time representing 20-hour clock. Okay, cool. So yeah, pretty self-explanatory, I would say. And then I would just say parts is equal to time dot split. You split them by the column, and then if length of parts is not equal to 2, then return false, right? So it has to be exactly 2. And then the hour is going to be the parts of 0. Minute would be like the minutes, hours, I guess. I guess let's just do hour and minutes. Okay, parts of 1. And then if I think it's a good idea to actually just convert it to integer at first. Oh, I guess this is already like in this format, so I don't need to check this part. Okay. If hour is greater than 24, return false. Greater than or equal than 24, return false. If minute is greater than 60, oh, I think there's no 60, right? So greater or equal than 60, return false. Then return true. I think this should just work. Let me just check. Oh, what? Runtime error. Okay. Minute is not defined. Oh yeah. Okay. Minutes. Okay. Cool. Yeah, and then in terms of space and time complexity, there's just nothing, right? It's O of 1, O of 1. So there's no loop. There's no like extra variable declaration and stuff like that. So sum up numbers. Okay. What is that? Codemaster just returned from shopping. He scanned the check of the items he bought, gave the resulting string to ratio org to figure out the total number of items purchased. Since the ratio org is a bot, he is definitely going to automate it. So he needs the program to sum all up the numbers which appears in the given input. Okay, I see. So basically, it's like you see a number, you just add up everything. Okay, so whenever there's a number, just add up. Okay, pretty interesting problem. What's the best approach to do this though? Constituent. It's not. Okay. There's definitely like a really easy way to do this, like the previous problem. So what I can do is like create a new string, new list, I guess, and keep all the digits, right? So just keep all the digits, and the rest of them I just can just replace it with space. And then once I've done that, I can just split it, and then what remaining is going to be the numbers. So let's just do that problem. Do that solution first, but that's going to be like O of n space complexity, right? So it's kind of a bad memory wise. So let's just do parts. I'll just do like clean or something. Oh, let's just do parts. Or C in input string, and then parts. If C is digit, then C dot append. C. Oh wait, sorry, no, parts dot append C, and then otherwise, then parts dot append empty space, and then what I can do is like numbers is equal to parts dot. Oh, I have to join it first. Join the parts, then split it up by the spaces. Now then I will only have numbers, right? Okay, so now I will have like array of numbers. So let's just print that out. And then return 0. Okay, console out, so like that, right? Okay, so now I have to do is like just sum these up, right? But before summing it up, I have to convert these strings into a integer, right? So the very naive way of doing this would be, I just declare like s and then for n in numbers, and then what I can do is like s plus equal. I have to convert it, right? So I have to convert the string into the number integer, and then I can just do this, right? So that definitely works. But this is kind of like really, non-elegant way, non-Pythonic way of doing it. So there is like a really good way of doing it. So instead of using this, what I can do is return. So let's copy this thing. Okay, so now you have list of strings, right? So to convert the list of strings into list of digits, the list of integers, what you can do is just use map operation, right? So map int, this would mean that I'm converting each of the strings into integer. Okay, now I have list of numbers, right? So which means I can just do sum, and that's it. So this is a much more Pythonic way of doing it. Okay, so this definitely works, right? So this is, but the thing is, it's actually, of n space complexity. So if you don't want this, then what you can do is basically like do like index by index, and then if it's a digit, go to the right, and then just keep on going until you hit the non digits, and then just keep multiplying by 10, adding that number, keep multiplying by 10, adding that number, right? So you could just keep on going like that. So that solution would be like of 1 space complexity. So yeah, I guess that's true. Yeah, it is true. So you can definitely do that, but this is definitely like a, it's a solid solution. It's not the best in terms of efficiency, but it's a good solution. Should I code that up? I guess I can code that up. I think we have time, so I think we can code that up real quick. So let's just code that up. Okay, so the S would be 0. And then what I can do is, what should be the best way to do that? Let me think. I think of having a while loop is actually pretty good in here. While I is less than length of what? Input string? Okay, input string. Then if input string of I is digit, then I guess I can do like n equals 0, and then which means n is equal to multiply equal 10, so multiply by 10, and then n okay, so let's just do this. N times 10 plus integer of input string of I. Yeah, so now I'm just essentially like, adding that digit, right? So if it's like maybe 12, so I'm seeing 1, then n is 0, so it's just going to be 1, and then but on the next iteration it's going to be like 12, right? So now in here what I can do is basically just say continue, right? So I thought they just continue on, or maybe not. Wait, let me think. I think I can do this and then continue. Okay, that works. And then so if it's not a digit, then I think I have to reset the n. Okay, and then just keep on going. I plus 1. I think this should work. Okay, and then finally, if it's not a digit, I reset it. But oh wait, before resetting it, I have to add it to the n. And then finally, also I have to return s plus n, because like if the string ends with a digit, right, then it would not go to this portion, I guess. Yeah, so it will just go here and then just continues on. It doesn't hit this one, right? So now I have to add that. Then I think this should work, but we'll see. Okay, yeah, it definitely works. So this solution is going to be like the most efficient, right? So there's no like additional space complexity, but time complexity is obviously going to be O of n. The space complexity is O of 1. So it's a pretty good solution. I guess it's the best solution out there. Okay. All right, so what's that? What's next? Given a rectangular matrix containing all the digits, calculate the number of different 2x2 squares in it. Okay. Different 2x2. Okay. I guess it's not that hard. Right? So let's do like row is length of matrix. It's always a good idea to have row and column defined like that. And then you can do like one line, right? So this would be like my way of doing it essentially. So just put it on one line. It's easier and cleaner to look at. And then I can like, start from 0 until row minus 1. And then for j in range, col minus 1. Okay. Because like it's going to be 2x2, right? So you have to end here instead of here, right? So it's going to be like that. And then we just analyze the 2x2s, and then I think we can create like a set. S equals set. And then what I can do is add like tuple, right? So there's 4 number tuple, and that's going to be it. So matrix of I, matrix of ij, matrix of I plus 1, j. Let's just go with like this, right? So that means I have to add the column first, then matrix I plus 1, j, and then finally I have to add I plus 1, j plus 1. Okay, so this will just give me all the unique values, and then just we can return the length of s, right? So this is a pretty simple problem. Cool. So we're just going to be utilizing the uniqueness of the set and then adding like a tuple, right? So if you don't know about tuples, then I would suggest reading up upon it. But basically, what you can remember is that you cannot add you cannot add a list into a set, right? Because list is a mutable object, a mutable variable. So essentially, you can understand it as this: you can add string to a set, right? So instead of like converting this thing into a string and then adding it to the set, you can just add like a tuple, which is essentially like a list, but it is immutable, right? So you cannot change it. You cannot change its size. You cannot append it. You cannot do anything with it, basically. I mean, you can just copy it essentially. If you want to overwrite it, then you have to overwrite it and delete it, overwrite it. It's just like strings, right? That's essentially it. Okay. So for the time complexity and space complexity of this would be, yeah, I guess the time and space are going to be both O of n times m, right? N is the row. Basically, it's like O of row times column, right? Both of them, space and time. So yeah, that's that. Cool. Digit product. Okay, what's that? Given an integer product, find the smallest positive greater than 0 integer. The product of whose digit is equal to the product. If there is no such case, -1. What? Okay. The product is that the output should be 26. Product is that the output should be -1. What? I didn't understand at all. Okay. Given an integer product, find the smallest positive greater than 0 integer. The product of whose digits equal to product. Find the smallest positive. Okay. I guess what it means is that if you multiply, 2 times 6, then it becomes 12, right? So you just have to find the smallest number that does that. Okay. Wow. This is a pretty hard problem, I would say. Because in order to do this, you have to basically find every divisors of the number, and then after you find the divisors, you basically like combine some of the numbers, right? So for example, like if let's say the one of the divisors was like I should explain this. Okay, so let's just take 32 is a bad example. Let's just do like 8 times 40, right? So 40 is an example. So this is going to be like, so I have to explain this thoroughly then. You have to make the number so that, what is it called in English? I'm trying to come up with that. What is it called? Like prime multiplication, I guess. Like, so that's like one of the theorems. So prime multiplications would be, okay, so 2 times 2 times 2 times 5. So this is going to be like every number can be a multiple of prime numbers, and that's unique, and that's a theorem, right? So that's like one of the fundamental theorems of math. So this any number can be dissected into like multiplications of prime numbers, and then that's unique. Okay, so that's basically the theorem. So you have to do this, and then after you've done that, you basically have to like combine some of the digits. Like, okay, so yeah, this is 222, so you have to combine it and then make it 8 in order to have like the smallest number, smallest digit, and then you sort it, and then it becomes like 58 or something like that. So it's a really hard problem. As you can see, like the dislike ratio, it's like super hard problem. This will take a while, I would say. Okay. I think there should be like a helper function that produces like all the divisions of a number. So divisors and then n. Okay. So those divisors would be, I think what I can do is go from 2 until square root of the number 0.5. Okay. So SQRT, and then let's just go with the +1 because range is like up until, right? So let's just go until that. Why square root, right? So I mean, you can go until technically like n, but that's just basically like wasting time. So this is like the most optimal way of doing it. So why square root, right? I think this video is not going to be the right place to teach that, but essentially, you can try something like this. So let's just look at 40, right? So if you want to list all possible like divisors of 40, then basically you divide it by, I think the 40 is a bad example. So 2, 3, 4, 5 is like 20. Okay, let's do 120. Okay, 120. So let's just try to find the divisors of 120, right? So you just start from 2, and then, okay, 2 is obviously a divisor, that's good. And then you go from to 3, right? And then, okay, 3 is divisor, that's good. And then you go to 4, and then you go to, but I mean, the 4 is not a prime number, so I think you also have to have a prime number. Okay, I have to remember that. Okay, anyways, and then you go to 5, right? And then you go to 6, but you cannot, I mean, what's the square root of 120? It's about 11, right? It's until 11. So you just go until 11 to check if there is like a prime divisors, and then you don't go up until then because you've already checked the half basically, and then you don't have to check the other half. So you can just understand it that way. Okay. So I think to find the divisors, you also have to get the prime numbers. So primes up until the square root, all right? Yeah, okay, let's just do that. So we have to find the prime numbers up until the square root of that. So square root is this, and then I think what I can do is like do math.for, and then plus 1, right? So that's going to be the square root plus 1 case up until that. I guess I don't have to do that. I think I can just do this actually. Okay, so that's going to be the square root, and then to find all the prime numbers up until something, then there's like a method called sieving method, right? So essentially what you do is you assume everything is a prime number up until the square root, and then you just say true, blah blah blah, right? And then you basically sieve through it. So primes of I think 0, 1, 2, 3, 2 is, I think we have to do a square root plus 1 actually. Let me think. So if you have 2, then yeah, okay. So that's it. And then essentially you just do like, okay, that one is false. Primes of 1 is also false. So 0 and 1 are not prime numbers, right? So we just say false. And then starting from 2, I can do that. 2, 3, 4, and then let me see. Okay, 4i in range, starting from 2 up until length of primes, like that. And then if primes of I is true, then we just basically, okay, we hit the first prime number, then we just basically mark every multiplication of those as like false, right? So the first thing, so in here, the list is going to be like f, and then true, blah blah blah, right? So everything is going to be like true except the first two. So we hit this part, and then it's obviously true. So now what we should do is like, okay, mark everything as even index as false. So we have to mark this as false because this represents 4. 4 is not a prime number, right? And then there's going to be another true in here. So we just make this into a false. So blah blah blah. So this is called the sieving method essentially. So if this is prime, then what I do is like do a let's just do a for loop actually. For j in range, it starts from I, but no, it's not starts from I. It starts from I multiplied by 2, and then it goes until length of primes, and then the jump is gonna be I, right? Yeah, I think so. Okay, so it jumps on each step by I. Okay, so on each of these, I'm doing is the primes of j is actually false. So this is the sieving method, and at the end of this result, everything is going to be prime numbers essentially. So for I p in primes, let's just do like primes is a really bad name. I just okay, so let's just do like numbers, I guess. But this is essentially like prime numbers. Okay, then if p is true, then prime numbers dot append I. You have to add the index essentially. So I primes enumerate. Okay, and then let's just print the prime numbers, right? Prime numbers. Okay. Okay, let's just test this function out. So divisors of product, then return 0. Yeah, this is obviously not going to be part of the code. Okay, console output 2, 3. Okay, that's good. And then what is there, like a large number? 450. Okay, so these are all the prime numbers, which is not the case, huh? Oh, what? This is so weird. Why it didn't give me an error? Okay, that's weird. Test 3. Okay, it's still not. So it didn't reach this point then. Primes through square root plus 1. So primes of I is true. This is so weird. Why is it not reaching this thing? Primes of I starts from 2 and then... Okay, obviously it should reach it. Length of primes. J, primes of J is false. That's so weird. So I don't think it reached here though. J. Okay. Yeah, it didn't reach here. So maybe it reached here. Okay, yeah, it did reach here, but J in range of I times 2. So let's go to test 3. Okay, it did reach, I mean, many times there, but it just didn't go through this loop at all. Why? So weird. Oh, yeah, I think, yeah, okay, I think this is it. So this is the start, finish, and then this is the jump, I think, yeah, okay. Yeah, that's it. Okay, so these are the prime numbers, right? 2, 3, 5, 7. Okay, yeah, now it's correct. Cool. Okay, now we have all the prime numbers up until the square root. Okay, cool. Okay, now we just do the divisions basically. While n is greater than 1, I think. Yeah. Okay, so if it reaches 1, my plan is to just keep on dividing it, right? Up until it reaches 1. So yeah. For prime in prime numbers, if n is divisible by prime, right, equals 0, then just divide it, right? So and then product, I guess divisors is equal to empty. And then okay, there's going to be like formatting issue, but we don't care about that currently. Okay, so now if it's that, then divisors dot append n, right? Oops. Oh, not n. Wait, append prime, and then n equals prime. Okay, and then return divisors. Okay, that's simply the algorithm essentially. Okay, and then let's just print this out. Oh yeah, I think let's just do like get divisors, right? And then divisors would be that, and then print the divisors. Okay. Oh, did we just do like execution time limit? Okay, that's bad. Prime numbers. Not sure what happened here. Let's just imprint the n. Console output. Oh, the number itself is a prime number. Wait, does that mean I have to go until? Okay, then I guess, yeah. Then I guess it's just that then, right? To get the prime numbers, yeah, if the number itself is a prime number. Okay. Oh, yeah, yeah, I think I was mistaken then. My technique that I was saying about square root is actually for checking if a number is prime or not for creating the primes. Okay, okay. Forget everything of it I said about the square root thing. So let's just do the primes saving method up until the number itself. Okay. So now it should work. Yeah. Okay. 2, 3. Okay. So I think what I can do is actually, if it's, if I find it, then I can just break it and then start from the beginning, right? So that way we have like a sorted, nice and sorted list of divisors. Okay, so if it's 12, then console output is 223. Okay, nice. I think that's what we want. All right, cool. Okay, so now we're like one step into it. So we have like 25, 26 lines of code that is only for getting the divisors. Okay. And then what happens after we get the divisors, right? So there are like many options, right? So if you have like 2, 2, 2, then we just replace it with 8 essentially. And then if we have 2, 3, then we replace it with 6. And then what else is there? If there's like 3, 3, we replace it with 9. So that's how we're just trying to minimize it, right? So, okay, what else is there? Is that it? Okay, so we have prime numbers like 2, 3, 5. Obviously, I cannot do anything with 5, so it's just 2, 3. Okay, I think this is it then. All right, but there has to be like order of things. So I think the most efficient one is like this thing. So if there are like 3 2s, then we just squish them up and then replace it with 8. And then if we can use either this one or that one, which one should we use? So if you have something like 2, 2, 3, 3, what would be the smallest number that you can do? It's actually like 6, 6, right? So 9, 4, 9. Oh, wait, it's actually 4, 9 then. So you have 2, 2 is also equal 4. Okay. So if you had this as of the prime divisors, then the minimum was like 49, right? So you can combine this with that. But if you combine this and then with that, that's going to be like 66, which is not correct, right? So the order of things should be, oops. So you have to do this first because this is the longest length. So you have to replace 3 2s with 8. That's the first thing. And then you do replace the 2 2s with 4s and then 3 3s with 9s. And then finally you just do this, I think. I think that's the order of things. Okay. Cool. Okay, so what's the best way to do that? Best way would be, or maybe the divisor should be actually like a dictionary or something. Let's do that instead. Yeah, I like it. I like the dictionary part. Instead of returning like a list of numbers, let's just return like a dictionary with key value, which is value is going to be the count, right? So let's do that. Divisors of prime is equal to divisors dot get prime or 0 plus 1. Okay, so now we don't need the break. We just do that. Okay, then let's just print out the divisors. Okay, this is good. Yeah, I like this one. Okay, cool. Yeah, because of this dictionary, I can actually use this approach. Cool. Okay, hold on. Let me think. If there is like a number. Oh yeah, right. Okay, okay. So there's like a one key thing. There's like a -1 thing, right? So if the number has a prime divisor that has 2 or more digits, then that's instantly false, right? So you cannot do that. So let's just check that. For key indivisors, if key is greater than 10, then just return -1. So that's like a given. Just checking for the I guess like the negative cases, right? So if it's not that, then we have a solution essentially. So okay, so this is checking for the negative stuff. Now what we can do is do the magic, right? So key value in D divisors. But should we do this because we're modifying the dictionary though? Okay, let me think. Okay, let's just do like D is equal to divisors dot copy. So let's copy the dictionary first. So then we can loop through it. So because like I'm going to modify this dictionary. So something like, if there's like 3 2s, then I replace it with the 8, blah, 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 right? Okay, so do I even need to do loops though? I don't think so. I don't think we should do loops because we don't need to iterate through every keys, right? Okay. Maybe this one is not needed then. Okay, let's just edit the dictionary right now. Okay, so if 2 in divisors, right? So now we have 2, and then count is divisors of 2, right? Okay. And then if count is greater than 2, I mean, let's just do greater or equal than 3, then we have to take it out and then replace it with 8, right? So, what should be the case then? I'm trying to think. Count like that, I guess. 8s, okay. So now a number of 8s is actually this. And then number of 8s, okay. But I have to subtract it from there. So let's do something like divisors of 8 equal to that, okay. And then the divisors of 2 is actually going to be count divided by 3. Okay, so that's going to be the remainder, right? Okay, so that's that. And then we do that again, right? Divisors of 2, if count is greater than or equal to 2. Oh yeah, this should be like this. If it's greater than or equal to 2, then we do the same thing, right? Kind of like this, but with 4. Oh, let's just do like count equals. Oh wait, why is there a count? Oh yeah, this is the count, and then we update the count. Equals count like that. Which means I can do this and then just say count. Okay. All right. So we update the count, which means I don't need this. So here I can do that. And then number of 2s would be that. Okay. Now, I think this makes sense. Okay. Okay, now what I can move on to the 3 3s, right? So what I can do is count 3. Let's just do count 3. Divisors of 3. Oh yeah, that's a totally different separate thing, right? Okay. If 3 in divisors count is that divisors 3, and then basically like this, right? So if count is greater than or equal to 2, then the 9 would be 3, 3, 3. Okay. That. Okay. Now it kind of makes sense. Okay. And then now we do the final thing, which is 2 and 3, right? So if 3 in divisors and 2 in divisors, now we do the sixes basically. Count 2 is equal to divisors of 2. Count 3 would be divisors of 3. Okay. And then if count 2 and count 3, I mean, those are both greater than equal than 1, that's for sure. So I don't need that. Okay, so now we just do divisors of 6 is equal to the minimum of count 2 and count 3, right? And then we update the divisors of 3 as I think what I can do is like that. Subtract it, and then same goes for 2. Okay, cool. Okay, so now finally, let's print out the divisors, right? Oh my god, this is like, I think this is the hardest problem in the code signal actually. Let's just do that. Oh, there's error, huh? Count 2 is not defined. Where is it? Oh, okay. Count 2. Okay, console output. 6 is 0, 4 is 1. Oh, I guess I have to check for the value then, because 3 in divisors. I guess what I can do is like this: if divisors dot get 3 and 0 is greater than 0, and divisors of get 2 and 0 is greater than 0. I can do that. Okay, and now it kind of makes sense. Cool. All right. Ooh, okay. Now what I should do is like do like digits is the list, and then loop through key values in divisors, right? And then digits plus equal key times value, which I'm trying to add like 3 one time, 4 one time, blah blah blah, right? And then we can print out the digits. Oh, divisors dot items. That's it. And then we have 3 and 4. Okay, that's good. And then essentially we just basically sort it, right? So digits dot sort, and then we convert this into a numbers, right? So I think the easiest thing to do would be just use it like a string, right? So what I can do is sort it and then join it, but before joining it I have to convert these integers into strings, which is we can do it with map like we did it before. And then okay, so after joining it, I think I can convert it into integer, right? Okay, so that's it. It didn't work. Why? It's 26. Okay, I think I did something wrong. Execution error. What is this? Product is 0. What? Index out of range. Okay, so what's the input? Okay, it's 0. If it's 0, then it's just 0, right? So let's just do that. If product is 0, then return 0. Okay. What is this? If product is 1, then it's just 1, right? So Let's just do like this. If product is less than or equal to 1, then return the product. Okay. Cool. All right, so in here, console, not console, return. All right, I'm pretty sure I've done something stupid. So which is, let's just print out the divisors. I'm really close, but I'm just not. So this part is definitely in the suspicious part, like these things. I think I did it wrong, so I'll just have to fix that. Print out the divisors. Okay, so we have 2, 2, and then 3 1s. Okay, I guess I have to do the 6s first. That's the order of things. So we have, yeah, I guess. So I have to do the 6s before the 2 2s. Like this thing. Yeah, I guess so. Okay, so I just do if 2 indivisors count is equal to divisors of 2. Okay. So it's kind of weird though. Like, why am I not understanding this? Maybe, okay. Do this before that. Okay, let's just do that. Still nothing. Okay, at least this one is passing. This one is passing. And then 450 is what? Return value 3556. So I'm returning. So for 450, I'm returning 3556, but the true answer is 2556. And the divisors are, let's just copy this. That. Okay, so what is the optimal solution? So 255, that's just it. That's good. And then, so 3 3 should be in the first then. Okay. Let's do this before the 6 then. Before 6. Okay. Oh, that still didn't help. Return value. But this should add 9 though. That's so weird. Okay, so 3 is definitely within that. So why didn't it add 9? Count. Oh, I think it's 2, 2, right? Count is 2. Yeah, it should be 2. Okay, so now that's passed. Product of 0 is 10. Okay, that's dumb. I guess that's like an edge case. If product is 0, then return 10. If it's 1, return 1. Okay, gotcha. Okay, so I think now we're getting there. Okay, let's just submit this. Why is it not working? Okay. All right. Oh my God, finally. This was a horrible problem. Like, I think I remember this like barely, but yeah, this was a horrible problem, and no wonder there's so many dislikes. This is a really, really hard problem though. Like, I don't think anyone can like solve it on the first try. You have to know so many stuff in order to solve this problem, like math stuff. So, yeah. Let's submit it again. Okay. All right. So, time complexity wise, I don't even want to get into it. It's just like horrible thing. Because there's like a sieving problem and stuff like that, right? So I think you can just uh, imply that it's like OFN, something like that. I don't think there is much to say other than it's OFN. Yeah. All right, go to the next problem. Hopefully, the next problem is going to be easier. Man, this video is getting longer than I thought. Okay, you are given an array of strings names representing file names. The array is sorted in order of file creation such that names I represent the name file created before. Okay, and after assume zero-based indexes. Okay, because all the files are unique names. So files created later with the same names as the file created earlier name, we should have additional case suffix. Okay, I see. Oh my god, this is also a hard problem. Not hard, I guess, but it's like at least medium difficulty. Should I just plow through these problems then? Yeah, let's just plow through these problems. Okay. Okay, so basically this is like a kind of like a naming system on the like on your desktop computer, right? So whenever you save a file, then like a copy or something, then it just adds like parentheses one at the end, and then it makes sure it's like there's no replacement, right? You have to make sure that there is unique file names there. So that's the idea essentially. So I think we can do this with dictionary and then just keep on the count, and then parentheses would be like the count, right? So let's just try to do that. For name in names, if so there's gonna be the result, right? Res is that. If name not in dictionary, then add it to the dictionary. Name equals 1. And also add it to the result. Print name result as it is, right? But if it is in the dictionary, then I think you could just get the count, right? So the dot name is the count. And then essentially res dot append the name plus there's like opening parentheses plus close parentheses, right? So I think this will give me a really close answer, but I'm not sure if it's going to be correct. But let's see. No, it's not it. There's can only concatenate string to integer. Okay, yeah, right. So that's why I think there's a good argument using f strings in here. So in Python you can do f strings, which these kinds of problems go away. Do that. Okay, I think this is it. Let's just do that. So essentially this means that if you just put f in front of a string and then these are variables with the curly braces, and then yeah, this just makes it much easier without adding like plus blah blah blah, right? Okay, so names. Okay, I think it just basically passed the simple tests, but not the complex test. Okay, in here, return value. Okay, so these three are correct, but this one is not correct. And this one too. Oh yeah, I forgot to increase the increment, then d name plus equals 1 after that. So if I do this, then probably it'll be something like 2. Okay, yeah, that's at least true. But in here, there's a problem. So if the name is in there, then I have to add one more doc. Okay, so let me think. So name is not in there, but if the name is okay, so I'm checking for doc1. Doc1 is not in my dictionary. So it goes here and then appends it to the list. of file names. Um, But there is already doc1 in my results, so I guess there should be like a set or something. I don't know, maybe like result set is going to be add name add this thing, I guess. But if name in result set, then I have to add like another parentheses on top of it. So this dot append f string name 1, something like that. But in here, this is gonna be, I'm not sure if this is the best way to do it, but let's just see if the test passes. Okay, it didn't work. Well, I mean, it did work on the first one, but it's not scalable. It didn't work on the second one or the third one. Yeah, this is at least like a medium difficulty problem. Oh my god. I think this is on LeetCode as well. Okay, so this is like 4 because if name not in the, I guess instead of having like a set, I should just add it to the dictionary directly. I think this is a bad approach to have a set as well. Okay, so instead of this, let's just focus. So we have dictionary, and then if it's not in the dictionary, then I'm just appending the name. But in here, I also should be appending this thing as like, if this in dictionary, let me think. But it just keeps on going, right? So what if it is there? Okay, so what if this thing is append D. Oh my god, I'm just can't think straight. My brain is too tired. Oh. So if this exists in the dictionary, obviously we cannot add it. Name not in dictionary. If name is in the dictionary, and then we just increase it. But if that increase is within the dictionary, I have to add 1 to it. But what if that is in the dictionary, right? So it just keeps on going like that. Let me think. So we have, let's just go with this input again. I'm just trying to understand the return value again. So this should return that. Okay, so we have dd1, dd2, dd1. Okay, so now we have wait, no, this is my return value, so this is wrong. Okay, so we are having dd, dd1. Okay, so these three are unique, so it just goes through. And then we add dd again, which, all of these are there. So now we just do 3, okay? So in this problem, if the dd comes in, it's actually goes here, and then it tries to do this thing, which okay, while I'll just do this while not in no, while in D. Okay, so if it keeps on repeating, then what we can do is name add 1, right? And then just keeps on doing that. And then finally add it, right? And then increase. Something like that, I think. Okay, let's just try that. And okay, so it passed that. It didn't pass this one. It didn't pass that one, which is problematic. So test 3, it didn't pass this one. Pass. Okay, I think I'm getting closer than I thought. Okay, let's work on this problem. So this thing is the input, and then the return value is okay. Yeah, so I'm trying. This is wrong, right? So why is that the case? So this one comes through. No, sorry. This one comes through, and then this goes through here. Okay, that's correct. And then I think my mistake is that I have to do the if dictionary is in there, I'm adding there. Right? Okay, wait. So I am using this thing, doc, okay? So it's in the dictionary. I add it to the dictionary, and then doc comes in, then it's already existing. So it becomes that in the dictionary, and then image comes in, that's unique, so that's fine. But this thing comes in. So now doc1 is not in the dictionary, so it just goes through here directly. But what I should have done was when I'm appending, I should have also put it in the dictionary then. If it is in the dictionary, doing that. This is going to be if it's not. Okay, so I think what I can do is D is 1 or something like that. Okay. Let's just do this. Oh, unexpected indent. Okay, there we go. Nice. Okay, so the trick was to basically put the resultant file name into the dictionary as well, like initializing it, right? So yeah, that was a trick. And then let's just do that. Okay, so this was a really hard problem actually. I mean, not very hard, but still like at least medium difficulty for sure. Okay, and the time and space complexity of this thing would be, I guess you have looping through the names and then doing technically like some sort of while loops. I guess the maximum can be like O(n) squared because this can loop through it twice, right? So yeah, I guess it's O(n) squared. But the space complexity is O(n). So yeah. So next question. Message from binary code. So we're almost there. We just have. Okay. You're taking part of escape room challenge designed specifically for programmers in the efforts of ASCII code. I think. Okay. 8-character code, which stands for, okay, gotcha. So essentially you just have binary string, and then you have to decode it using 8 by 8, right? So basically like you take the first 8, decode it, and then the next 8, and then the next 8. So this is a much easier problem than what we've encountered before. So let's just start. MSG like that, and then I in range of start from 0 until the end, then just go by 8 by 8, right? Okay, so the character would be code from I until I plus 8, right? That's going to be the character, but we have to, so that's going to be the binary string. We have to decode this into just a regular number, right? So binary string to number, I think we can do like deck or something. I forgot. Like, I think there is a way. Let me see. Binary string to int Python. Okay, from binary int, it's like int. Okay, it's just int. Okay, gotcha. So int comma 2. So that's going to be the character, the ASCII character. And then to convert it into like a real character, you just use char, right? So, and then the resulting character, you can just add it to the message.append. And then just return the joint string MSG. Okay, cool. So in here, the time and space complexity is pretty straightforward. The time complexity is just O of n, however long it is. And the space complexity is, it can be O of n too, right? It's just n divided by 8, which is O of n. So O of n, O of n. Right, next question. Spiral number. Okay, I think the idea is that you're going to be creating like a 2D matrix that just spirals around, right? So 1, 2, 3, and then goes down 4, 5, and then goes to the left, and then goes to the up, goes to the right, blah blah blah. So I don't think there's a better way of doing this other than just to like simulate the exact process of the spirals, right? So I think we should just do that. So let's do that. Cool. All right. So first off, we have to create the matrix, which, let's just start from 0, right? So n is going to give me like rows, right? So just one row, but I have to create like multiple rows, right? So for that, I would have to do that for in range n, like that. Okay. So this is really, really confusing if you are just seeing it first time. So essentially, whenever you want to create like a 2D array in the Python, you have to do this. There's just no way of doing it everything else. So essentially what this means is that you are creating like like 0 times n, like a list, and n times. You're just doing like a for loop, right? So this is how you create like n by n matrix. So I would just suggest you just, get familiar with this notation or memorizing it or whatever. But yeah, this is how you create like 2D array in Python. Okay, and then I will just create like a direction. I guess let's just call it D, and then start from 0, and then direction 0 means basically like, let's just comment here, right? 0 means right, 1 means down, and then 2 means left, 3 means up. So that's the direction of the spiral, right? So I'll just I'll just keep like keeping track, like increment D whenever I change direction, and then just use that. Okay, so since there is like n by n, then let's just do like a counter. Count is equal to 0, and then do like a while loop, right? While count is less than n times n, then count plus equals 1. So whenever there's like a number filling, I just use the count, increase the count. Okay, so if d divided by 4 is equal to 0, that means we're going to the right, right? So maybe I should do while loop or something. Let me see if it's that. Let's just start with the count with 1. because we are going to be using that to fill these numbers up. So 1, 2, 3, 4, blah, 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 right? So maybe like matrix of x and y both starts from 0, 0. X and y is equal to count. And then let me think. Maybe I should just mark the first one as 1 and then go to the right. I guess maybe that's a good idea too. Okay. Matrix of 0, 0 is already 1. So count starts from 2, right? And then what I can do is like it's going to the right. So y plus 1 is less than n. If it's that, then fill it up, right? Or maybe I can do this. If this, fill it up, but if it reached the limit, right? Then if it's like n, then basically increase the direction by 1 because we want to rotate it. Yeah, I think that's it. Yeah, I think this should be okay. Okay. So essentially we just do like elif one. Maybe I can do a switch statement, but in Python, I think the switch statement it was introduced in later versions. So let's just do like elif for now. So 1 means down, right? So down means x plus 1 is that. Y is 1, x is that. Okay. And then L if d of 4 equals 2, that means it's going to the left, right? So left, I'll just copy this thing. It's going to be pretty similar to that. So my n minus 1 should be greater than or equal to 0. Then subtract it. And then that. Okay, that's good. Okay, and then else would be copying this thing. Except it's going to be a subtraction and then greater than 0 and then subtract it. Okay, cool. So I think this should just work. And then return matrix. Oh. Which one is this? This should be here. It should be here. Y plus 1. Okay, it should be here. It should be here. Okay, let's just try that. Oh, it should be here as well. All right, so everything is wrong. Astro, let me see. Console output, return. Okay, 1, 2, 3. I guess I didn't do a good job of keeping track of the directions. Let me see. So 1, 2, 3 is good. That's good. And then we move on to here. X plus 1 is less than n. Then matrix count, increasing the count by 1. So it starts with 0, 0, and then 1, and then goes to, okay, those two are good, but in here it's kind of silly. Not really sure what happened on 4, why it got skipped. So count. So I think there should be like a really, really careless mistake somewhere. So let's just do like print count x and y. Console output, okay. So you have 0, 1, 0, 2, which is good. And then again 0, 2. So it didn't get increased, which is bad. So you go to the right, but you have to go down, right? So it didn't go down, which means it should have increased the x, right? So it didn't go here, I guess. Yeah, let's print the D as well. So 0, 0, it is 1. Yeah, I mean, it did go here. It should have. X plus 1 is less than n. X plus 1 count y. I mean, this looks okay, but there's definitely a mistake somewhere. Let's print this up in here, but with extra characters. Okay. Going to the right. No, it's going to down. 5, 6, 7. 5, 6, 7. What? Why is 7 going down as well? Okay. So I think this thing is being troublesome. Let me think. So we go to the right, and then whenever we reach, okay, so whenever we reach the end, then we go. Okay, so we reach the end, and then we do. I guess. Okay. That's why probably. Okay, so if I do something like this, then it probably should work. But this is kind of like a bad way of doing it. Let's just check. Oops. I'm wondering this should just fix it. Return value. 1, 2, 3. Oh yeah, right. So yeah, okay. So this one is like kind of working, right? But this is just going around the circles. It's going around the edges, not going inside. So I have to code that up as well. So if that and is 0, essentially, yeah. So I have to add these to everywhere. That if that okay, I think output exceeded. Okay, it's obviously time limit exceeded. Return undefined. Count -1 plus. But that's so weird though. We will reach. Maybe it's just decreasing it and increasing it constantly. So let me just try to do these actually. I don't really like this approach. Okay, console output, return value. No, it didn't even work. Oh yeah, right. So the current. Okay, I guess I should do y is 1, right? That's the current one. Okay, no, that's not it. This should be +1. This should be plus here, and then this should be -1. This should be negative here. Okay. Okay, now it's kind of working, but let me just quickly uncomment these up. Okay, there we go. Nice. Okay, so yeah, I guess this problem works. I mean, this solution works. So let's just go with this and then submit it. Okay, yeah, the time and space complexity of this would be just over n squared, right? So yeah, it's pretty much it. So it's kind of like a simulation that we need to keep track of the directions and, plus and minus ones, stuff like that. So which is not that hard, but it is going to be tedious once you, like you've just seen, right? So it's going to be tedious to keep track. So yeah, let's go to the next question. Is this the last one? Okay. Sudoku's number, the objective is to fill out line and so that each column, blah, blah, blah. Yeah, let's just check the given Sudoku numbers represent the correct Sudoku solution. Okay, gotcha. All right. So, I mean, if you know the Sudoku problem, then it will look pretty easy, pretty easy to understand. But if you don't know, let's just quickly go over through, right? So essentially, you have 9 by 9 numbers, so 81 numbers, right? So in a Sudoku game, what the rule is that every row has to have numbers 1 to 9, every row, and every column has to have numbers from 1 to 9, okay? And as well as every 3 by 3 boxes like this, like you have 9 boxes, right? So every one of those 9 boxes have to have numbers from 1 to 9. So that's a valid Sudoku. None of these, if any of these rules break, then that's not a valid Sudoku. So let's just go through that. So let's just check the rows and columns first. So essentially, for I in range of 9. So this is going to be the rows. So rows go from 1, 0 to 9, then J in range, columns go from there. Okay. So essentially, I guess, yeah, I think this is good. So numbers, let's open the set, and then basically you keep adding to the set and then check the length if it's 9 or not. So that's the idea. Numbers.add of grid I and J. Then if length of numbers is not equal to 9, then return false, essentially. So is that right? Let's just check. So you have the first row and then add 9 numbers. I think this is good, yeah. Okay, so now for the columns. So for the columns, what I like to do is I just do J as a reverse, right? So essentially it's going to be exactly like this, but I and J is going to be reversed. So let's do the J first, and then in here I, and then this should just work out, yeah. Okay, so now we have the rows and columns all cleared up. Now we can move on to the 3 by 3s, right? So for I in range 0, 9, 3 goes increased by 3, right? In range 0, 9, 3. Okay. Right. So these would be the starting coordinates of each of the boxes. But now you have to go like right 3 and then down 3, right? So for I in range 3, for JJ in range 3, right? Okay. So let's just do numbers is the set. And then do numbers.add grid of I plus II, J plus JJ. So that's going to be that. And then we can just do this. Okay. And then finally return true. So I think this should work. Yeah, exactly. So I can't believe I did it on the first try. That's honestly amazing. Okay, cool. So yeah, it's just really simple. Just the trick is to have clear structure to check it, check the rows, check the columns, and check the 3 by 3 boxes, right? And then the method to checking is just using the numbers set, and then if the length is 9 or not, essentially. So let's just submit this. Okay, cool. So now the arcade intro is 100% complete. And I think this took, okay, so this video is like 1 hour 45 minutes. So this is the part 5, right? So I think this took me like maybe 5 or maybe like a maximum 6 hours to solve. So, which is, pretty reasonable time, I would say. Okay, so yeah, let me know if you have any other questions or concerns, and then I'm not sure if I'll be doing other stuff because I don't think these are that useful. I'm not sure. I haven't tried it, so maybe I'll do it, maybe I will not. But it's essentially like the intro is done now. Yeah, and then maybe I'll do another video of like, is doing the arcade really worth it, right? So maybe there's gonna be the next video talking about that. But yeah, I'm glad I've solved it, and then put it into a video format, and then it's gonna be there forever, right? So yeah, see you guys in the later videos then.